డే 22 అని పెట్టిన పిల్లలు కూడా కన్ఫ్యూజ్ అవుతారేమో ఎంగారా. డే 22 అని పెట్టినావు. సరేలే ఓకే. Right. Good evening. So, last day we discussed the gain margin, calculations of gain margin. And today we'll calculate the gain margin as well as face margin. So here listen. What I told, what is the conclusion I given in the last day? If order of minimum pay system, MPS means minimum pay system, less than or equal to 2, then gain margin is what? Infinity. Omega PC does not exist. Omega PC does not exist for first order. Omega PC equal to infinity for second order. That I told in the last day. If order of the system more than or equal to order of MPS more than 3, more than or equal to 3, then gain margin equal to what I told? K marginal by K desired value. And omega PC equal to omega n. We solved problem also. And in case, next what I told, if K desired is not mentioned, then K desired equal to 1. That means gain margin equal to K marginal value. And omega PC equal to omega n. Radians per second. Up to this, we discussed in the last day. Now, come on. K desired means how many times system gain is increased. Gain increases means gain margin decrease. K desired means how many times gain increased. Last day problem, what we taken? GH equal to what we taken? Last day also I told K desired is called how many times gain is increased. S plus 1, S plus 2. What is the characteristic equation? S cube plus 3S square plus 2S plus K equal to 0. Internal product 6. External product K. In case I will make it NK, N times gain increased. N times gain increased. What happened? Gain margin, man. Here gain margin equal to how much? K marginal. That equal to how much? 6. In case I will take NK, then what happened? In case if I take NK, what happened? N times gain increase. That is called a desired value. How many times gain you are increasing? That is called desired. N plus 1 by S plus 2. S cube plus 3S square plus 2S plus NK. What is the gain margin? Internal product 6, external product NK. external product NK. Now tell NK equal to 6. K marginal na. So K marginal equal to what? 6 by N. That is called gain margin. Gain increases by N times means gain margin decreased by N times. Gain increased by N times. Then gain margin decreased by N times. Then gain margin reduced by N times or decreases by N times. That's all. Next problem. Calculate the face margin. Calculate face margin for G of S, H of S equal to 1 by S into S plus 1. Come on, calculate the face margin. G of S, H of S equal to 1 by S into S plus 1. Come on, do it. Come on, Bhaiya. First, what is the formula for face margin? Formula for face margin. Face margin equal to 180 plus angle of GH of J omega at omega GC. At omega GC. Now, come on, do it. First, find omega GC. Step 1. Find omega GC by using magnitude equal to 1. Step 2. Find face margin. Come on, do it. First, find omega GC. Omega GC, magnitude 1. What is the magnitude? Tell. 1 by omega root of omega square plus 1 equal to 1. Come on, find the answer. Omega root of omega square plus 1 equal to 1. Omega square plus 1 equal to 1. Then get the omega value. Omega power 4 plus omega square minus 1 equal to 0. Then assume x equal to omega square. Then x square plus x minus 1 equal to 0. Find the roots. Find the roots, apply root. Then you will get omega. Find the roots. Come on, 58.28. Very good. Now, come on. Get the screenshot on page 1. Next, come on. Get the x value and then find first omega GC. What is omega GC? Omega GC. Come on. What is omega GC? .786. Very good. So if you solve it here, omega equal to omega GC. Omega equal to omega GC. That equal to 0.786 radians per second. Next find the magnitude at omega GC. So we got omega GC now. Then find the phase margin. What is the phase margin? 180 plus angle GH at omega GC. So phase margin equal to 180 plus, what is angle GH tell? Minus 90. 1 by S and minus 90. Na? S plus 1 means minus tan inverse of omega. At where omega GC means 0.786. Substitute 0.786. Here is substitute 0.786. Come on, get the answer. If you solve this, phase margin equal to how much? 51.83 na 52 na. How much you got? What is the phase margin? 51.83 degrees. Okay. They'll send the na already recorded this PDF file they are sending na. Last day I think he sent it na. 51.83 degrees. You will send it, no need to worry. Right. 51.83 degrees. Right. Right. Next problem. Next one. Find the K value. So simply, first you have to find omega GC. Then you have to find the phase margin. Okay. Next. Find the K value. Next problem. Find the K value. Find the K value. Find the K value to get the phase margin equal to 30 degrees. For G of S, H of S equal to K by S plus 1. K by S into S plus 1. Come on, do it. So, find the K value to get the phase margin equal to 30 degrees. Use the phase margin formula and then get the answer. Use the phase margin formula first. Phase margin equal to what is the formula? 180 plus angle of GH of J omega at omega GC. So 30 degrees equal to 180 degrees plus what is the angle GH tell? What is the angle GH? Minus 90 minus tan inverse omega at omega GC. Minus 90 plus 90 means 90. Come this side, minus 60. Minus 60 equal to minus tan inverse omega. At where? Omega GC. Minus minus plus. Omega equal to tan 60. Tan 60 means root 3. So radians per second. This is called omega GC. Omega equal to omega GC, root 3. Then find the magnitude. At omega GC, magnitude equal to 1. What is the magnitude? K by, write the magnitude omega root of omega square plus 1 equal to 1. Now substitute omega GC at where? Omega GC. Now substitute omega GC K by, what is omega GC tell? Root 3. So root 3 plus omega square means 3 plus 1 equal to 1. Then K equal to what? 2 root 3. K equal to 2 root 3. K equal to 2 root 3. That's all. If you select K 2 root 3, then you will get the phase margin is 30 degrees. When you taken K1, we got phase margin 51 degrees almost. K increases, then phase margin is decreased here. Sorry, that and all secondary. Next, one more problem. Right. Next question. Find the K value. Find the K value. K value to get phase margin equal to 60 degrees. To get phase margin equal to 60 degrees. A bit, B bit. Find the K value to get gain margin equal to 20 dB. For G of S, H of S equal to K by S into S plus 2 into S plus 4. Come on, do it. Come on, Guruji. First problem, you know it. Same method is solved. A. So phase margin formula what? 180 plus angle of GH of J omega at omega equal to omega GC. Uh, 60 equal to 180 plus angle GH what? Minus 90 minus tan inverse omega by 2 minus tan inverse omega by 4 at omega GC. Then 90, 30. 30 equal to 90. If come this side, minus 30 equal to minus tan inverse of omega by 2 minus tan inverse of omega by 4. All minus, make it plus. Then get the answer. So simplify. Enter into calculator. You can get it tan inverse of omega by 2 plus tan inverse of omega by 4 minus 30. We can enter this equation into calculator. Directly we can get the answer. Enter tan inverse omega means you take x, tan inverse x by 2 plus tan inverse x by 4 minus 30. Enter. After entering, don't press equal to 0. Kuch bhi nahi, don't press equal to. Just enter tan inverse x by 2 plus tan inverse x by 4 minus 30. If it is fx, 991 ms calculator. Actually, calculator not allowed. You have to go by manual only. No alternate now. When there was the calculator, so we used to simply enter like shift to, after entering equation, shift to calculate, again shift to calculate. If you enter, wait for 5 to 10 seconds, then it displays the answers. If it is fx 991 es or es plus, just you have to press shift. After entering equation, shift, calculate, equal to press, then it will display the answer. Here solve manually because calculator not allowed. Na? Solve it manually, we'll get the answer. In virtual calculator, you don't get it. In virtual, it is not there. Come on. So what is the answer? If you solve this, you'll get omega GC. I think 0.70 will get. If you solve this, omega GC is 0.70 will get. omega equal to omega GC. That equal to 0.719 approximately, I think 0.72 radians per second will get. 0.72 radians per second. No doubt. Okay, na? Next. Then find the magnitude at this omega GC. At omega GC, magnitude equal to 1. So that means K by omega root of omega square plus 4 root of omega square plus 16 equal to 1. Then K by, come on, substitute omega GC. Get the answer K. You substitute here K value, omega value substitute. What is omega GC? Substitute omega GC 0.72. Then get the K value. What is K? I think 6.2 you will get. You solve it. K equal to 6.2 you will get. K equal to 6.2 will get. ठीक है ना? Solve it. K equal to 6.2 will get. $6.2. ठीक है? Next. Second bit you solve. B bit. Solve the B bit. Come on. So what is given? Gain margin equal to 20 dB given. Now first find omega PC. So angle GH of J omega equal to minus 180 degrees. Find omega PC. Minus 90 minus tan inverse omega by 2 minus tan inverse omega by 4 equal to minus 180 degrees. Then solve this. Tan inverse omega by 2 plus tan inverse omega by 4 equal to 90 degrees. So tan inverse of omega by 2 plus omega by 4 divided by 1 minus omega square by 8 equal to 90 degrees. Take tan is the other side. Tan 90 infinity. Tan 90 infinity. Infinity means denominator 0. 1 minus omega square by 8 should be 0. So then omega PC equal to root 8 radians per second. Next, find the gain margin. What is the formula for gain margin? Minus 20 log of magnitude of GH of J omega at omega PC. Gain margin 20. 20 equal to minus 20 log of magnitude means what I will get? K by omega root of omega square plus 4 omega square plus 16. Omega square plus 16. 20 cancel. If you log eliminate, it will become 0.1. Then K by root omega PC 8 na root 8. 8 plus 4 12. 24. Solve for K. We'll get 4.8. That's all. K is 4.8. Very good. K is 4.8. Very good. That's all. So like this, you have to get the answer. Okay. Next problem. Completed na? Right. Next. Calculate gain margin and phase margin. for g of s h of s equal to 1 by s plus 5. Come on, do it. Calculate gain margin, phase margin. Come on. Calculate gain margin, phase margin. Go by procedure. Better why shortcut and all. You'll do the mistakes. Shortcut means you have to find RH criteria. K marginal, you have to find gain margin equal to K marginal by K desired. K desired value you have to find. K marginal by gain margin gives the K desired value. K value means K desired only. Come on. Infinity. PM is undefined. Gain margin infinity. Right. See here, it is a order 1 minimum pay system. MPS order equal to 1. That means gain margin infinity omega PC does not exist. I told you the last day also. Minimum pay system, MPS, minimum pay system. Order less than or equal to 2, gain margin infinity omega P. Today also I told you. Last day I drawn border plot also. Omega PC does not exist. What about the phase margin? So next phase margin. For phase margin required omega GC. The magnitude equal to 1. So 1 by root of omega square plus phi square equal to 1. Omega square plus phi square equal to 1. Now tell. Is it satisfied? It never, you solve it, you will get imaginary. You solve this, you will get omega GC is, I think, plus or minus j root 24 you will get. Omega GC equal to plus or minus j root 24. Invalid point. Invalid point. Invalid point. Simple logic here. You substitute omega 0, what is the magnitude? Tell. You substitute omega 0, what is the magnitude here? It never satisfied, first of all. It never gives the magnitude of 1. Because if omega 0 if substitute, you will get 1 by 5, means 0.2 you will get. Omega infinity if substitute, you will get 0. That means this transfer function gives the maximum magnitude of 0.2 only. This transfer function gives the maximum magnitude. Substitute any frequency. The magnitude cannot cross 0.2 at all. But you are making equal to 1. How it is possible? It is not possible. You are making equal to 1, which is not possible. So simply make it what? Simply make equal to, substitute omega 0, omega infinity, that's all simply. If the magnitude always less than 1, blindly we can write omega GC does not exist. Omega GC does not exist. Anywhere they give transfer function, if we ask the phase margin, just substitute omega 0, omega infinity. Observe the magnitudes. If in case magnitude always less than 1, the magnitude always less than 1, blindly write omega GC does not exist. Or you calculate, you will get imaginary, invalid. Invalid you are getting means omega GC does not exist. Omega GC does not exist. So once omega GC does not exist, blindly we can write phase margin is infinity. Blindly we can write phase margin is infinity. Phase margin is infinity. That means whenever the plot or transfer function, whenever the plot or transfer function. Whenever the plot or transfer function maintains less magnitude than 1, less magnitude than 1, less magnitude than 1 at all the frequency range, magnitude than 1 at all the frequency range, at all the frequency range, then phase margin equal to infinity. Then omega GC does not exist. Then omega GC does not exist and phase margin is infinity. Be remember this. So that means before calculating phase margin, you should verify the magnitude. Before calculating gain margin, you check the order of minimum phase system. For gain margin, order of minimum phase. For phase margin, we have to verify the what? Verify the what? Magnitude at omega 0, omega infinity. That's all. Just if you do it, so you will get the correct answer. Don't do blindly, don't get the wrong answers. Okay, na? Next. So like this, you have to calculate the what? Gain margin and phase margins. Next problem. One more problem. Okay. Next problem. In a GH plane, in a GH plane, the Nyquist plot, of loop transfer function, G of S, H of S equal to pi into e power minus 0.25 s by s, pi into e power minus 0.25 s by s, passes through negative real axis, passes through negative real axis at the point is, passes through the negative real axis, passes through the negative real axis at the point is, passes through the negative real axis at the point is. Come on, do it. What they are asking, if you draw a Nyquist plot for this or polar plot, whatever it is crossing the negative real axis. It is crossing the negative real axis. For example, it is a negative real axis. This is where it is crossing this negative real axis, they are asking. Where it is crossing negative real axis, they are asking. Where it is crossing means what is this point? Tell this is minus 180 degrees, negative real axis. That means this is a magnitude at what? Omega PC. Intersection point is called magnitude at what? Omega PC. You have to find the magnitude at omega PC. That's all. So right, passing through negative real axis means, 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 passing through negative real axis means it is an intersection point. It is an intersection point with minus 180 degrees. With minus 180 degrees. It is the intersection point with minus 180 degrees. Find the intersection point with minus 180. Come on. Find the intersection point with minus 180. How to find intersection point with minus 180? With minus 180. Angle GH equal to minus 180. So minus 180 equal to minus 90 minus 90 minus 0.25 omega. Minus 90 minus 0.25 omega into 180 by pi. 180 by pi into 180 by pi. Okay, na? Why? Because this is in radians, convert into degree. Now solve this, all minus become plus. Then 90 equal to 25 into this means 45. 45 degrees omega by pi. Then 2 times. That means omega PC. It is omega PC intersection point minus 180 means omega PC equal to 2 pi radian. 2 pi radians per second, omega PC. Then find magnitude at omega PC. So magnitude at omega PC. What is the magnitude? Tell. Exponential term magnitude 1. Exponential term magnitude is 1. That means pi by omega. At where? Omega PC. Then pi by omega is called 2 pi. Pi by 2 pi means how much? 0.5. Magnitude is 0.5. That means it is a negative real axis, na? That means minus 0.5 comma J0. Intersection point with minus 180 is, so I'll write in the next page. Intersection point with minus 180 is, intersection point with minus 180 degrees is minus 0.5 comma J0 in rectangular. Minus 0.5 comma J0. Intersection point with minus 180 is minus 0.5 comma J0. That's all. Okay, na? Continue this problem again. Continue this problem. Come on. Calculate the gain margin and phase margin to the above problem. Calculate gain margin and phase margin to the above problem. To the above problem. Calculate gain margin and phase margin to the above problem. Come on, do it. We got magnitude at omega GC, na? Magnitude at omega GC, how much you got? Omega PC. Magnitude at omega PC, how much you got? Magnitude at omega PC, they how much? 0.5. 0.5. Now, what is the formula for gain margin? Gain margin equal to what? 1 by magnitude at omega PC. That means 1 by 0.5. That equal to 2 in linear. In linear. In dB means, gain margin in dB means, what I will get? Simply minus 20 log magnitude at omega PC. How much? 0.5. You solve it, plus 6 dB will get. Plus 6 dB will get. Gain margin equal to plus 6. That's all. Next, find the phase margin. To find the phase margin. So find the phase margin. For phase margin, first we required omega GC. So omega GC means magnitude equal to 1. All right, what is the magnitude? Tell to the given function, what is the magnitude? Pi by omega. Exponential term magnitude is 1. So pi by omega equal to 1. That means omega GC equal to what? Pi. Radians per second. Then find the phase margin. 180 plus angle GH. What is angle GH? Tell. Minus 90. Minus 90 minus 0.25 omega into 180 by pi. 180 by pi. Now at where? Omega GC. Omega GC. Substitute omega GC here. This is pi. Then pi cancelled. Then solve this. Then you will get the phase margin. How much you are getting? This is 135 plus at 45 degrees will be. Like this, you have to calculate the face margin. Okay. Right. Next one. Next problem. Find the K value. Find the K value for system stability. For system stability. For system stability. For G of S, H of S equal to K into E power minus 0.5 S, you take no problem. Divided by pi. Divided by S. G of S, H of S equal to K into E power minus 0.5 S by S. Come on. Find the K value for system stability. How to find? So like this question they ask, you should not go by RH criteria. Approximate means you can go by RH. So whenever they ask the range of K value for exponential term, then you have to go by gain margin concept. So what is the condition for stability? In the polar plot I told. What is the condition for stability? The condition for stability is what? The condition for stability is what? Closed loop stability. What is the condition for closed loop stability? The condition for closed loop stability is the magnitude at omega PC should be less than 1. Then gain margin become greater than 1. Magnitude at omega PC less than 1 means automatically system stable. Automatically system stable. Magnitude at omega PC should be less than 1. Come on, find it. First find omega PC. Angle GH of J omega equal to minus 180. Come on, minus 180 equal to minus 90 minus 0.5 omega into 180 by pi. Come on, get the answer. What is the answer? So what happened? All minus become plus. 90 equal to, I think 90 degrees omega by pi. So I think omega PC equal to pi. Pi radians per second. Then find the magnitude. Magnitude at omega PC. What is the magnitude? Tell K by omega. K by omega. So omega is pi. That means K by pi. So for stability what? For closed loop stability, what I told, magnitude at omega PC less than 1. Magnitude at omega PC less than 1. That means K by pi less than 1. So K is less than pi. And default is greater than 0 by default. That's all. Like this, you have to find the what? Range of K value for closed loop stability. Like this, you have to find the range of K value for closed loop stability. Okay, na? No need to find omega GC, no need to check omega PC, kuch bhi nahi. Simply find magnitude at omega PC, put it less than 1. That's all. That is a condition for stability. Automatically you will get the answer. Okay, na? Last problem. But they don't ask like these questions because without calculator it is very difficult. But still, why? Because there are many questions. You'll find some questions in previous gate and not IES, special gate questions you'll find. Because calculator was allowed at the time, they used to ask this type of questions. But last 3-4 years questions you observed, you don't find single question like this. Calculate gain margin and face margin. Calculate gain margin and face margin for G of S, H of S equal to e power minus S by S into S plus 1. Sometimes they will ask, what is the effect of exponential term or transportation delay term on system stability? Means blindly we can say that due to exponential term, the system become less relative stable because it is adding negative angle. Na? You check it. Exponential term adding always negative angle. Here minus na minus 0.5s. So negative term adding. Due to that negative term, then omega PC is going to be reduced. Omega PC reduced. So that's why. So gain margin, face margins are reduced due to exponential term. Due to exponential term, due to transportation delay term, due to exponential or transportation delay terms, due to exponential term, due to exponential mean transportation delay only. Exponential terms or transportation delay, due to transportation delay, the relative stability decreases. The relative stability decreases. We remember. The relative stability decreases. Relative stability decreases. That means what I can say, gain margin reduced as well as face margin also reduced. Gain margin reduced and face margin reduced. Omega PC reduced. So gain margin, face margin reduced. Be remember this. Okay, na? Remember that. Okay. Now come on, solve it. So first face margin you have to calculate. First gain margin calculate. Gain margin. Omega PC. That means angle GH equal to minus 180 degrees. So minus 180 equal to bolo minus 90 minus tan inverse omega. Next minus omega into 180 by pi. You solve and find omega value. Anybody? All minus, make it plus. You solve it. Is it possible? I don't think it is possible. You solve it. Then he came to know. So without calculator, not possible. Tan inverse omega plus 57.3 degrees omega. This is 180 by pi minus 90. You solve this equation. You have to go by trial and error method. It takes more time. You have to substitute omega value such that you should get the 90 degrees. It takes the more time. You have to go by trial and error. Or if you calculator allowed, directly we can get it. You can enter into calculator. We can enter into calculator. And then I told now FX 90, 91. That you press it, automatically you'll get the answer. That's why they don't ask like these questions nowadays. They're not asking. So without calculator, not possible. Use the calculator and get the answer. Use calculator. So get the answer. Without calculator, that they don't ask you, no need to worry. So then if you solve this, you'll get omega PC is, I think 0.86 you will get. Omega PC is, if you solve this, I think 0.86, I think. Or otherwise, what you have to do, if you ask like this question, find omega PC. If you ask, you enter option A and enter sum should be 0. Enter option B, enter option C, which is equal to 0. That is the omega PC. In case they ask the omega PC, go from option to question. Go from option to question. So I think you will get 0.86 radians per second. You will get 0.86. So I think 0.86 you will get. Next, find the magnitude at omega PC. Magnitude at omega PC. What is the magnitude? 1 by omega root of omega square plus 1. You substitute this omega PC value, will get 0.88 you will get. Then gain margin equal to 1 by 0.88. That equal to 1.13 in linear scale you will get. 1.13 in linear. They may ask ask this question for phase margin. They may ask this question for phase margin. Phase margin they can ask. So what is GH tell? E power minus S by S into S plus 1. They can ask phase margin. So why? Because, so why they can ask means, for phase margin first required omega GC. At omega GC magnitude 1. For omega GC, exponential term becomes 1. That's why 1 by omega root of omega square plus 1 equal to 1. 1 by omega root of omega square plus 1 equal to 1. Now find omega GC. Already we solved this equation. We got omega GC is 0.786. We solved this equation already. So 0.786 we got it. Then get the phase margin. Phase margin is 180 plus angle GH, that is minus 90 minus tan inverse omega minus tan inverse omega minus omega into 180 by pi. You solve it, substitute omega GC here. You substitute omega GC how much? 0.786 is all substitute and solve it. I think phase margin you will get it 6.78 you will get. 6.78 degrees you will get. You can check it. Okay. So this is calculations of gain margin and phase margin. With this, frequency domain analysis completed. You try to solve all the problems in the volume 1 related to frequency domain analysis, means border plots, polar plots, and Nyquist plots. That and all given in one chapter only in the volume 1. Try to solve all that questions. Okay, na? Next we'll start the state space analysis. Okay. Actually, we have to close the syllabus by tomorrow. I asked Saturday 2 hours class, so I'll close on Saturday. Saturday I'll take 6 to, most probably Saturday I'll discuss this chapter frequency domain analysis questions in volume 1 and state space. Whatever the possibility is there, that questions I'll discuss. Okay. Syllabus most probably majority portion I'll complete by tomorrow. I'll see if possible. Okay. Process control another master will take. Controllers PID controllers compensators tomorrow I'll cover. Controllers compensators tomorrow I'll cover it. Okay. If any small portion pending, then I'll cover on Saturday. By Saturday 8:30, I'll try to close the syllabus. Okay. Right. Next. State space analysis. State space analysis. You try to solve all the problems in frequency domain analysis. State space analysis. This is very important for GATE especially. Actually, this chapter is not there for IES. It is for only GATE IA. So the chapter very, very important. But sometimes they are asking a questions in IES also, in objective especially. So that's why, listen. So what is the state here, first of all? What is the state? Actually, in syllabus, we are not having all the topics. You can refer the syllabus, GATE syllabus. In state space analysis, we are having only one topic, that is solution to the state equation. State space representation and solution to the state equation is there. But we'll cover complete chapter briefly, so that any question comes, you can able to solve. So first of all, say state. What is the state? Process control for only instrumentation students. It is not for ECE. ECE process control not there. It is for only instrumentation. ECE only control just. ECE, even ECE, controllers not in syllabus, but better to attend the controllers and compensators because both are linked. Process control for only instrumentation, not for ECE. So I come to the subject, state space analysis. What is the state? State gives the future behavior of the system. State gives the future behavior of the system. Future behavior. Future behavior of the system. Future behavior of the system. Future behavior of the system. Based on what? Present input and past history. Based on present input and past history. Based on present input and past history. Past history. So state gives the future behavior of the system. State gives the future behavior of the system based on present input and past history of the system. So I can write it. What is the past history? Past history is nothing but initial conditions. Past history is nothing but initial conditions. Past history is nothing but initial conditions. Initial conditions. So initial condition. This initial conditions only described by the state variables. Or the other way I can say, the past history is described by state variables. Past history described by state variables. What are the state variables? What are the state variables? Means you can say voltage across capacitor. We are having only three elements, na? R, L, C. Linear elements means three only, R, L, C. So R is, it cannot store it. R is not having any past history. L is having a past history. It stores the energy in the form of current. Capacitor having a past history. It stores the energy in the form of voltage. That means generally state variables are nothing but voltage across capacitor and current through the inductor. So current through the inductor. So what is the definition we can give? State gives the future behavior of the system. State gives future behavior of the system. Future behavior of the system. Future behavior of the system based on present input, past history. Based on present input and past history of the system. Past history, present input and past history of the system. Past history of the system. Past history of the system. Okay. The past history described by state variables. 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 ठीक है ना? Right. Write it. Past history described by state variables. Process control triply also it is not there. Yeah? It is for only instrumentation. Right. In this batch, triply students are there. No triply na in this batch. Right. Next. For triply also process control not there. Only one topic is there, that is this one. Mechanical systems. On that they are not asking any questions from last event. That is there from the many years, but till now there is no single question on that mechanical systems. Right. Write it. Next. What I told? Past history described by the state variables. Past history described by state variables. That's all. Okay. Write it. Next page. Past history described of state variable. See, the resistive circuit is not having any state variable because resistive circuit cannot store any energy. That's why the resistive circuit is called memoryless system. So listen here. If you take a resistive circuit, for example, I'll take here 1K, 1K, for example, 1K here also I'll take 1K. So what I told, the future behavior should be depends on what? Present input and past history. For example, if I take a resistive circuit, I'll take here T, here VI if I take, here for example, I'll take 10 volts. What is the output? Tell, what is the output? V naught equal to what? VI into 1K by 2K, 1K plus 1K, 2K. That means we are getting what? 0.5 times of VI. So that means we are getting output directly without knowing the past history. First of all, resistors are not having any past history. Here the output depends on only input, but not depends on the what? Past history. So output depends on only input. Output depends on only input. Only input depends on only input because the resistive circuit not having any past history. Because the resistive circuit is not having any past history. Is not having any past history. Any past history. Any past history. Hence, no state variables are exist. No past history. Hence, no state variables are exist. Hence, no state variables are exist. 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 Hence, no state variables are exist. ठीक है ना? No state variables are exist. Then listen. No state variables are exist. That's why the resistive circuit is called memoryless system. The resistive circuit is called memoryless system. The resistive circuit is called memoryless system. Memoryless system. The resistive circuit is called memoryless system. Memoryless system. Resistive circuit is called memoryless system. It is a memoryless system. If in case I'll take RC circuit, for example, I'll take RC circuit. What happened? If I take the RC circuit, bolo, what happened? If I give here, for example, if I give here a step input, for example, if take here step input of 10 volts, what is the output? Tell, what is the output? The output depends on here input as well as how much voltage accumulated across capacitor. That means output depends on input and past history of the capacitor. That past history is called state variable. So in RC circuit, output depends on input, and past history of the capacitor. 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 So in RC circuit, output depends on input and past history of the capacitor. Hence, RC circuit having state variable. Hence, RC circuit as state variable, as one state variable, that is voltage across capacitor variable, that is VC, voltage across capacitor, that is VC, voltage across capacitor. So if you ask the number of state variables, number of state variables, if you ask number of state variables, if RLC circuit is given, if RLC circuit is given, then the number of state variables equal to then the number of state variables equal to the number of state variables equal to the number of state variables equal to sum of inductors and capacitors, sum of inductors and capacitors, sum of inductors and capacitors, sum of inductors and capacitors. Next, in case differential equation is given, if differential equation is given, differential equation is given, differential equation is given, if differential equation is given, then number of state variables equal to number of state variables. SV means state variable. Number of state variables equal to order of the differential equation equal to order of the differential equation, order of differential equation, order of differential equation, order of differential equation. Okay, number of state variables equal to order of the differential equation. Next, standard form of the state model. Right. Next, standard form of the state model. Standard form of state model. Standard form of state model. Right. Right. What is the standard form of state model? X dot equal to AX plus BU is called what? X dot equal to AX plus BU is called what? State equation. State equation or dynamic equation. Even they used to call dynamic equation. Dynamic equation. Y equal to CX plus DU. CX plus DU. It is called output equation. Output equation. Where X is what? Where X is called state vector. X is state vector. State vector. U is input vector. Input vector. Y is output vector. Y is output vector. Next, X dot is differential state vector. X dot is differential state vector. ठीक है ना? Next, A is, what is A? A is state matrix. B is, what is B? Input matrix. C is output matrix. D is transmission matrix. Transmission matrix. So these are the matrix names. Okay. Right. Next one. Right. Next one. This is the standard form of state model. Now here they used to ask the 4 variety of questions, especially in the state space. That is state model to transfer function, one variety. They used to use the state model. First step here, you have to learn it how to write the state model. First step, system to state model. System. System means system should be converted into state model. System should be converted into state model. System means system may be represented by differential equations. System may be represented by transfer function. System may be represented by block diagram or signal flow graph. System may be RLC network. For all these things, how to write state model, you should learn it, first step. Then second step is, they used to give the state model, they'll ask the transfer function is. They'll give the state model and they'll ask the transfer function is. Third step is STM, they used to ask. State transition matrix. State transition matrix. State transition matrix, they used to ask. State transition matrix. Then fourth one is controllability and observability. Controllability and observability. These topics we have to cover it. Okay, na? Come on, one by one we'll cover. Come on. First, put the heading. State model to the differential equation. State model to the differential equation. State model to the differential equations. State model to the differential equations. Come on, do it. First, I'll take one differential equation, y triple dot plus 3y double dot plus y double dot y dot plus 7y equal to 10u. So to this, you have to write the state model. To this, we have to write the state model. Come on, write it. First step, yeah, how many state variables required? What is the order? Tell here. Order of the state model 3. So number of state variables is 3. Number of state variables equal to 3. Number of state variables equal to 3. Number of state variables 3. Now come on, create the 3 state variables. Let first convert y into state variable, y dot, y double dot, y triple dot, all should be converted into state variables. So come on, let y equal to what? X1. Let y equal to x1 you consider. So y converted into state variable of x1. This is equation number 1. Next, y dot equal to what? X1 dot. Y dot equal to x1 dot. That equal to new state variable will create. That is x2. So this is equation number 2. Next, y double dot, because y double dot also should be converted. That means x2 dot. X2 dot. That equal to what? X3. This is equation number 3. So now, how many state variable? 3. We created 3 state variable. But number of differential state variables always equal to number of state variables. Be remember. The number of differential state variables must be equal to number of state variables. So, how many differential state variables we required? 3. But how many we are having? Only 2. So, one more we have to create. That means y triple dot equal to x3 dot. So, this is equation. Don't write equal to x4 because 3 state variables only. 3 state variable, 3 differential state variable. This is equation number 4. So like this, you have to create the state and differential state variable. Now substitute these equations in the given system. Substitute above equations in the given system. Substitute above equations in the given system. Above equations in the given system. In the given system. Above equations in the given system. Given system. Come on, substitute it. What I will get? Y triple dot is nothing but what? X3 dot. Plus 3. Y double dot is nothing but what? First priority state variable. If state variable available, substitute by replace by state variable. If state variable not available, replace by differential state variable. State variable available, replace by state variable. If it is not there, differential state variable. So why triple dot? Triple dot is called x3 dot. State variable not available. Next, y double dot is nothing but x3. State variable available na. So that means I can write 3x3 plus 5x2 plus 7x1. 7x1 that equal to 10u. Now tell what is x3 dot. Tell x3 dot. Differential state variable should be left. Remain all are right. Differential state variable should be left. Remain all are right. So x3 dot equal to 10u minus 7x1 minus 5x2 minus 3x3 minus 3x3. So this is equation number 5. This is equation number 5. This is equation number 5. So now, this is now put all these equations in the state model. Now put all these equations in the state model. Okay, na? So how to write it? Now listen. Write the state model. Come on, x dot. X dot means x1 dot, x1 dot, x2 dot, and x3 dot. X dot means x1 dot, x2 dot, x3 dot. X3 dot is equal to A. Here x1, x2, x3 plus B U. Now come on, x1 dot. X1 dot linked with what? Tell x1 dot. Equation of x1 dot you observe. This is x1 dot. X1 dot linked with only x2. X1 dot linked with only x2. X2 dot linked with only x3. So now tell x1 dot linked with x1 dot linked with only x2. That means with x1 0 with x2 1. It is linked with 1 only. Na dekho. X1 dot equal to x2. 1 time x2. That means 1 only. So 1. And with x3 dot 0. And with input to 0. Next, x2 dot. X2 dot. X2 dot linked with only x3. X2 dot linked with only x3. That means 0, 0, 1. With x3 na. With x1 0. With x2 0. X3 1. With input to 0. Next, x3 dot. X3 dot linked with x1 by 7. X2 by 5. X3 by 3. So that means what happened? X1, x3 dot linked with x1 by minus 7. Next, minus 5, minus 3. So minus 5, minus 3 with input by 10. Check it with input by 10. 10u with input by 10u. X3 dot linked with x1 by minus 7. X2 by minus 5. X3 by minus 3 with input by 10. Then y, output matrix, y. Y is linked with only tell. Y is linked with what? Y is linked with only x1. There go, equation y. Linked with only x1. That means y equal to 1, 0, 0. Into what? X1, x2, x3. That's all. Into x1, x2, x3. Like this, you have to get the answer. Okay, na? This is called the what actually controllable canonical form. This is called actually controllable canonical form. Controllable canonical form. Controllable canonical form. That is CCF. Actually, state models are not unique. To the same problem, we can write in a what? Observable canonical form. If we are able to find these roots, then we can write in diagonalization form, Jordan canonical form. State model is not unique. Be remember. State model is not unique. State model is not unique. There are 4 forms of state model. SA means state model as state model. That is, first one is controllable canonical form. CCF. Second one is observable canonical form. OCF. Third one is diagonalization canonical form. DCF. Fourth one is Jordan canonical form. JCF. There are 4 forms of state model. These are the 4 forms: controllable canonical, observable canonical, Jordan canonical form, 4 forms. See here, they'll ask for just 1 mark. They'll ask for just 1 mark. Okay. So they ask for just 1 mark. So we cannot go by procedure like this. So it is wasting the time. It is wasting the time. So that's why we can write directly answer. Listen, how to write directly answer means listen. Listen. What is the main equation? Tell y triple dot plus y triple dot plus 3y double dot. 3y double dot plus 5y dot plus 7y equal to 10u. Okay, this is the equation. Listen. In controllable canonical form, listen all of you. In controllable canonical form, especially in CCF form, the A matrix is like this. Generally, how it is means 0, 1, 0, 0, 0, like this go on, it will be there. Next 0, 0, 1, 0, 0, like this go on. This one will be go on, shift the diagonally like this, 0 and so on. This one will be go on, shift the diagonally. One is go on, shift the diagonally. Dekho here, one is go on, shift the diagonally. Next, last row is nothing but lowest to highest with opposite sign of the coefficient. Last row is nothing but lowest to highest with opposite sign of coefficients. With opposite sign of coefficients. Opposite sign of coefficients. For example, dekho, last row you check it. -7, -5, -3. But here the coefficient should be 1. In case it is not 1, you divide the equation. In case it is not 1, you divide the equation. Take lowest to highest opposite sign of coefficients. So -7, -5, -3, -3, -7, -5, -3. Next, this B matrix is 0, 0, 0, 0, 0, 0, 0. This input coefficient. This 10 is a last element in the B matrix. 10 is a what? Last element in the B matrix. Last element in the B matrix. Generally, 10 is a last element in the B matrix. 10 is last element in the B matrix. 0, 0, 0, 0, 0, 0. This is the what? Input coefficient. That's all. Next, C is 1, 0, 0, 0, 0 only. Why? Because while starting converting, y equal to x1 only will take. That's why. So, why C matrix is 1, 0, 0, 0, 0 only. C matrix is 1, 0, 0, 0 only. That's all. Okay, na? That's all. Okay. Now, one problem I'll give, you write the directly answer. Just one problem I'll give, you write the directly answer. Okay? Come on. Complete, Anna? So I'll give one problem, write in CC. In case if you want in OCF, listen, one more thing, listen. In case you want in OCF form, that means observable canonical form. In case you want in observable canonical form, first write in CCF. First you write in CCF. After writing CCF, so after writing CCF, be remember, A matrix in OCF is nothing but A matrix in CCF of transpose. Of transpose. Just apply the transpose. A matrix in OCF is nothing but A matrix in CCF of transpose. So apply the transpose tell. What is the transpose tell? So 0, 1, 0 means row converted into column. So 0, 1, 0. Next 0, 0, 1. Next what you are getting? -7, -5, -3. -7, -5, -3. That's all. Next, B matrix in OCF is nothing but B matrix in OCF is nothing but C matrix CCF of transpose. Of transpose. That means what happened? What is C matrix? 1, 0, 0. Transpose means convert row into column. So 1, 0, 0 like this. Next, C matrix in OCF is nothing but B matrix in CCF of transpose. Of transpose. So simply be remember this. So that means what? 0, 0, 10. So 0, 0, 10. 0, 0, 10. So like this you have to write the answer. Like this you have to write the answer. Okay, na? Okay. In case here 10 is not there means, here in case 5 is there means here 2 will be there. The input coefficient is a product of first element in the C matrix and the last element in the B matrix. But generally standard form, that 10 will be included as a last element only, no doubt. This 10 will be included in the last element. In case 10 is not there means, you go by the procedure, you write a transfer function to the what? You write the transfer function to the differential equation. You write the transfer function to the differential equation and then write the state model and then write the state model. How to write the state model from the transfer function I'll discuss. If 10 is not there here, that means that fellow given answer by finding the transfer function. So to the differential equation, we know now to find transfer function. From the transfer function, we'll write the state model. There I will explain how that 10 will be divided into B and C matrices. That I'll discuss it. Okay, na? I'll discuss in the transfer function to the state model. Okay. Next, one problem, you write the directly answer. Come on. Write the directly answer. You write in only CCF form. Y4 dashes plus 2y3 dashes 4 double dashes plus 6y dash plus 8y equal to 5. Come on, write it. So what is the answer? A matrix you tell 4 by 4 matrix. A matrix is 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Take lowest, highest with opposite sign of coefficients. Come on, -8, -6, -4, -2. B matrix is what? 0, 0, 0, 5. C matrix is what? 1, 0, 0. That's all. Next, one more problem. Next, we'll go for state model to the transfer function. Next, state model to the transfer function. state model to the transfer function. Okay. Right. State model to the transfer function. Write it. Write the state model to the given transfer function. Write the state model. SM means state model to the given system. Y of S by U of S equal to 2S plus 3 by S square plus 5S plus 6. S square plus 5X plus 6. Transfer to state model. Everything, whatever we are discussing, starting, that is just a transfer. All the things you have to transfer to state model. That's all. Write it. Right, come on. How to convert, how to transfer to state model. Listen, Bhaiya, solution. Simple logic, I'll tell, you follow that. See, in the last case, in the especially differential equation case, in this case, you observe y triple dot is written as what? X3 dot. Y triple dot is written as X3 dot. That means what I can write? Y triple dot is written as what? X3 dot. X3 dot. That means it is 3 differentiation. That means I can write S power 3. S is called d by dt, na? 3 differentiations. So I can write S power 3. That means simply S power n equivalent state variable is nothing but what? S cube equivalent state variable X3 dot. Na, S power n equivalent state variable is Xn dot. That's all. S power n equivalent state variable is Xn dot. Just you have to convert the given system into state variable. S power n equivalent state variable is Xn dot. How many state variable here? 2 state variable, n equal to 2. So 2 state variables. Come on, convert it. Come on, convert it. There are 2 state variables. There are 2 state variables. So to n equal to 2. So 2 state variable. 2 state variables. Come on, directly convert. So S square equivalent state variable is what? Tell. S square equivalent state variable is what? X2 dot. X2 dot. Can I write equal to X3? X2 dot. Can I write equal to X3? No. X3 means it is going to be third state variable. So you should not write X3. You should not write X3. Next, S power 1 coefficient can be written as what? X1 dot. Can I write equal to X2? Yes, we can write, because X2 means it is second state variable only. So we can write equal to X2. Equal to X2. Next, S power 0 coefficient can be written as what? X1. S power 0 coefficient can be written as X1. Why it is written as X1 means, in case if I write the differential equation, the transfer function convert into differential equation, what I will get here? Y double dot I will get, plus 5y dot I will get, plus 6y equal to what I will get? Tu dot I will get, plus 3u I will get. Yes or no? Yes or no? So that means what happened here? Y equal to x1 only, na? Dekho. Y equal to x1. Y equal to x1. So y equal to x1. That's why S power 0 coefficient, take it as x1. S power 0 coefficient, take it as x1. So the directly given transfer function we are converting into state models. Given transfer function we are converting to state variables. Now S power 1 equivalent state variable, tell x1 dot, x1 dot. That equal to what? X2. That equal to x2. X1 dot, that equal to x2. S power 0, tell x1. S power 0 is x1. That's all. Now make it separate numerator and denominator. Now make it separate numerator and denominator. Okay, na? Numerator and denominator, make it separate. Come on, first denominator I'll write u equal to what I can write? U equal to x2 dot plus 5x2 plus 6x1, 6x1. Then x2 dot equal to what I can write? U minus 6x1 minus 5x2 minus 5x2 minus 6x1 minus 5x2. So this is equation number 2. This is equation number 1. Differential state variables only we required. That's why x1 dot is a one equation, x2 dot is another equation. Now write numerator term. You write the numerator. Y equal to what? Tell 2x2 plus 3x1. That's all. This is equation number 4. This is equation number 4. Now put it into matrix. Now put into matrix. That's all. You will get the answer. Now put into matrix. Then you will get the answer. Okay, na? Put into matrix. Then you will get the answer. Come on, man. Come on. Put into matrix. Then what happened? 2 by 2 matrix, na? So x1 dot. x2 dot. Equal to come on. X1 dot linked with what? X1 dot linked with only x2. That means 0, 1 with input to 0. Next, x2 dot linked with x1 by minus 6. x2 by minus 5. Input by 1. And similarly, y matrix. Y. x1, x2. Bolo. Y is linked with x1 by 3, x2 by 2. That's all. It is a state model. That's all. It is a state model. Yes or no? It is a state model. That's all. You will get the answer. Okay? Okay, na? Right. So like this you have to write. But this is by the procedure. But directly we can write. How to write directly means listen. Now I'll explain how to write directly. Listen, Bhaiya. Listen here. Page. I'll transfer to next page also. Right. Now listen. How to write directly? Listen. Listen, Bhaiya. Simply denominator gives the A matrix. Denominator gives the A matrix. Last row, A matrix given by 0, 1, 0, 0, that one shifting as usual. Just like controllable canonical form. Controllable canonical 0, 1, 0, 0, 0, 0, 1, 0, 0. That one shifting diagonal as usual. So denominator gives the matrix. Take the lowest to highest with opposite sign of the coefficients. With opposite sign of coefficients. With opposite sign of coefficient. Take lowest highest with opposite sign of coefficient. That means minus 6, minus 5. Minus 6 and minus 5. Then numerator gives the C matrix. Numerator gives the C matrix. C matrix. Take lowest to highest with the same sign of coefficients. Take lowest to highest with the same sign of coefficients. Right. Right. With the same sign of coefficients. Take lowest to highest with the same sign of coefficients. Take lowest to highest with the same sign of coefficients. Same sign of coefficients. So देखो C matrix देखो C matrix. So 3 2 3 2 3 2 here. So देखो 3 2 same sign. Next, what is the B matrix means? 0 0 0 0 0 0 0 0 1 or in case, listen, 0 0 0 0 1 or in case, listen all of you. Right. 1 minute. One minute, eh? Right. Right. Listen, all of you listen. One minute. Right. Right. Listen. See matrix 3 2. In case, listen. I'll put here K. For example, I'll put here K. In case, I'll put here K. Then what happened there? In case I'll put here K. Then one possibility is we can write 3K and 2K. That is one possibility. We can write here 3K and 2K, one possibility. The other way is, if that K, if you take it other side, then it will become KU. Then it will become KU. If you take K other side, it will become KU. That means here KU. That means here KU. That means x2 dot linked with what? Minus 6 by x1, minus 5 by x2 with input by K. That means here you will get the K. You will get the K. That means the common factor in the numerator is the last element in the B matrix. The common factor in the numerator. Common factor in the numerator. Common factor in the numerator is the last element. Is the last element in the B matrix. Last element in the B matrix. Be remember. Is the last element in the B matrix. In case here not there K means it will be 3K and 2K. So it will be 3K. For example, here I can take common 2, for example. If I take it common 2, here what I will get here, tell 1. Here 1.5. Here 2 will get it. In case if I take it 2 common, what I will get? Yes plus 3 by 2 means 1.5. That means what I will get? Lowest to highest opposite side means here 1.5. Here 1. Here 2 I will get. Here I will get the 2 like this. Okay, na? Like this we can write the directly ABC matrix. Directly we can write the ABC matrix. Okay? Now one problem you write directly. You write one problem directly. Come on. Come on, one problem you solve it. Write the state model. Oh. 2s power 3 4s square plus 6 divided by s power 5 3s power 4 4s cube 5s square plus 7s plus 9. Come on, write it. Take numerator 2 common. Take the 2 common in the numerator and then write it. Take numerator in the numerator 2 common and then write. In the numerator take 2 common and then write. Y of S by U of S. S cube plus 2S square plus 3 divided by S power 5, 3S power 4, 4S cube. Come on, write the answer. Completed? Right. So I'll write A matrix. So here order 5 by 5. So 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. Next take it last row. Come on. So take opposite sign. -9, -7, -5, -4, -3. Next B matrix. 0, 0, 0, 0, 2. C matrix. Below 3, S power 1 missing means 0. Again 2, 1. S power 4 also missing 0. 5 elements, na? This is the C matrix. Like this, we can write the state model directly. Okay, na? I told na if S power coefficient is divide with 1. Here other than 1 is there, divide and then do it, man. Make it 1 always S power 5. Just like differential equation only. Everything you make it. Okay? Right, next. One more problem. Write state model. Y of S by U of S equal to 1 by S plus 1. S plus 2. Come on, do it. So here you should not expand. Whenever factor form is given, then you have to write DCF form. Diagonalization canonical form you have to write. Whenever they given in a factor form, then you have to write in DCF form. Diagonalization canonical form you have to write. First find the partial fractions, all of you. Find the partial fractions, all of you. Find the partial fraction, all of you. Come on. Write it. Partial fractions you find out. Solution. Y of S by U of S. Don't write in controllable canonical form. Don't write in controllable canonical form. Okay, na? Right, correct. Partial fractions, correct. Right. So S equal to -1, you put it. Here -1 means +1. Here -1 means 2. So that means 1 by 2. 1 by 2 by S plus 1. Plus S equal to -2 means I think you will get -1. Because -2 means -1 plus 1. So -1 by S plus 2. Next S equal to -3 means -3 here means -2 -1. So 1 by 2. 1 by 2 S plus 3. Now this can be written as, come on, get the answer. This can be written as y of s equal to 1 by 2 u of s divided by s plus 1. Then plus minus 1 u of s by s plus 2 plus 1 by 2 u of s by s plus 3. 1 by 2 u of s by s plus 3. Now this can be written as y of s equal to, I can write x1 of s plus x2 of s plus x3 of s, where if apply inverse Laplace transform, I can write y equal to x1 plus x2 plus x3. This you can take it as equation number 1. But where x1 of s equal to, 1 by 2 u of s by s plus 1, and x2 of s equal to minus 1 u of s by s plus 2. x3 of s equal to 1 by 2 u of s by s plus 3. Now come on, cross product it. S x1 of s plus x1 of s equal to 1 by 2 u of s. Then s is called d by dt. Apply inverse Laplace transform by all these things. Apply ILT. S x1 dot, if you can write it as x1 dot plus x1 equal to 1 by 2 u. Equal to 1 by 2 u. That means x1 dot equal to what? 1 by 2 u minus x1. This is equation number 2. Similarly, second equation, cross product. S x2 of s plus 2x2 of s equal to minus 1 u of s. Equal to minus 1 u of s. Apply inverse Laplace transform. Then x2 dot plus 2x2 equal to minus 1 u. Then x2 dot equal to minus 1 u minus 2x2. Minus 1 u minus 2x2. This is equation number 3. Similarly, here s x3 of s plus 3x3 of s. 3x3 of s is equal to what? 1 by 2 u of s. Then apply inverse Laplace transform. So x3 dot equal to x3 dot plus 3x3 equal to 1 by 2 u. x3 dot equal to 1 by 2 u minus 3x3. This is equation number 4. That's all. This is equation number 4. Now put in a matrix. Then you will get the answer. Now put in the matrix. Arrange in the matrix. You arrange in the matrix. Come on. Write the matrix. x1 dot, x2 dot, x3 dot. Now come on. Right, listen, all of you listen. Right, first x1 dot linked with x1 by minus 1, input by 1 by 2. So x1 dot linked with x1 by minus 1, x1 dot linked with x1 by minus 1, x2 0, x3 0, input by 1 by 2. Next, x2 dot linked with what? x2 by minus 2, input by minus 1. So that means x2 by minus 2. With x2 minus 2, remain all are 0, input by minus 1. Next, x3 dot. X3 dot linked with what? Input by minus 3, input x3 by minus 3 input by 1 by 2. So 0, 0, minus 3 input by 1 by 2. Similarly, y matrix. Y is linked with what? x1 by 1, x2 by 1, x3 by 1. So 1, 1, 1. x1, x2, this is the function. This is the state model. Like this, you have to write the state model. You write the state model like this. What happened? Tell here. All the elements you got in what? Diagonally. Check it. All the elements you got it diagonally. That's why it is called diagonalization canonical form. So these are called poles. These are called poles or eigenvalues. These are called poles or eigenvalues. And B matrix coefficients are partial fraction coefficients. B matrix elements are what? Partial fraction elements. Partial fraction terms. Partial fraction terms. C is always 1, 1, 1 only. C is always 1, 1, 1, 1, 1, 1, 1 only. C is always 1, 1, 1. Like this, you can write that directly. But here one thing is there. What is that means? B and C matrices are interchangeable. Here B and C matrices are interchangeable. Here B and C, we can interchange the B and C matrices. How to interchange means, listen. See, the same terms, for example, right, B and C interchangeable. Why means, for example, this is, I'll take like the other way. For example, method 2, if I consider method 2, this I consider method 1. This is the answer for method 1. Here I'll write method 2 answer. Listen. So what I can do here, listen. Here I can write here 1 by 2 x1 I can write. Here I can write 1 by 2 x1 I can write. Here I can take minus, or I can do here 1 by 2 now. U of s by 2. Here I can write minus. Here I can write less only. I can put 2. Like this I can write. 1, 1, 1. Now what I can write here? 1 by 2 x1 minus 1 x2. Then 1 by 2 x3. That means you apply inverse Laplace transform 1 by 2. Then minus 1. Then 1 by 2. 1 by 2. Then what is x1 dot tell? What is x1 dot? 1 by 2 already included. That means what is x1 dot? Simply u of s by s plus 1. What is x2 dot? U of s by s plus 2. Here u of s by x plus 3. This 1 by 2 not there. This 1 by 2 not there. This 1 by 2 not there. Here also minus 1 not there. Minus 1 not there. Minus 1 not there. Then here also 1 by 2 not there. Here also 1 by 2 not there. Here also 1 by 2 not there. Then if you write the answer for here, what will get answer tell? Here x1 dot, x2 dot, x3 dot. Come on, what I will get tell? What I will get? A matrix is same. There is no difference in the A matrix. There is a difference in the what? B and C matrices. So then what happened here? So that's why whenever they'll give in the diagonal form, you should observe what are the elements are there in the B matrix. Then we have to decide the C matrix. So what happened here? Tell. If you go here, what happened? X1 dot linked with input by 1, x1 by minus 1. So that means 1, 0, 0, x1 by minus 1, input by 1, input by 1. Next x2 dot bolo with x2 by minus 2, input by 1. Dekho x2 dot input by 1 and here minus 2. x3 dot input by 1 and x3 by minus 3. That means 0, 0, minus 3, input by 1. Input by 1. And if write the Y matrix, what I will get here? Partial fraction coefficients you will get. In Y matrix, what you are there? 1 by 2 minus 1, 1 by 2. That means what happened? 1 by 2 minus 1, 1 by 2 of x1, x2, x3. And what you observed here? B and C matrix elements are interchangeable. In the diagonalization form, in DCF, diagonalization canonical form, B and C matrices are interchangeable. B and C matrices are interchangeable. Okay, be remember this. Okay, B and C matrices are interchangeable. Okay. Next, one problem I'll solve for diagonalization canonical form. One problem. Most of the time CCF only they are asking, not asking any another thing. But still you should know. Next, diagonal one problem. Right state model. Right state model. One by s plus 2 whole square into s plus 3. Whenever repeated roots are there, then you have to write in DCF form. Repeated roots are there. Here 2 roots are repeated. Then you have to write in Jordan canonical form. Repeated roots are exist means repeated roots are exist. So JCF form, Jordan canonical form. Jordan canonical form. Come on, do it. Come on. Partial fractions you find. First partial fractions, you find it. Find the same procedure, just like DCF only. Partial fractions, y of s by u of s. What is the partial fractions? A by s plus 2 whole square plus b by s plus 2 plus c by s plus 3. Find ABC values. Y of s by u of s. I think A is 1. 1 by s plus 2 whole square. B is minus 1. Minus 1 by s plus 2. C is again plus 1 by s plus 3. Then y of s can be written as 1 into u of s by s plus 2 whole square minus 1 u of s by s plus 2 plus 1 by plus 1 u of s by s plus 3. S plus 3. Now come on. Then I can write inverse Laplace transform. Now this can be written as y of s equal to 1 x1 of s minus 1 x2 of s plus 1 x3 of s. Here partial fraction coefficients included in the C matrix only. Apply inverse Laplace transform. If apply inverse Laplace transform, y equal to x1 minus 1 x2 plus 1 x3. This is equation number 1. Next, where right, where x1 of s equal to u of s by s plus 2 whole square. Space not sufficient. She'll go by next page. Where x1 of s equal to u of s by s plus 2 whole square. x2 of s equal to u of s by x3 of s equal to u of s by s plus 3. That's all. Now, come on, this can be written similar to last problem only. Similar to last problem only. Okay. Next, this can be written as, listen. What I written? I have to write equation again. x1 of s equal to u of s by next x2 of s equal to x3 of s equal to now come on, cross product. No. Listen here. This can be written as x1 of s can be written as u of s by s plus 2. Can I write? Into 1 by s plus 2. x1 of s can be written as u of s by s plus 2 into 1 by s plus 2. You can write it now. Then now tell u of s by x by u of s by s plus 2 is nothing but what? x2 of s. Now substitute here x2 of s. Substitute x2 of s. That means what is x1 of s? Tell x1 of s equal to x2 of s divided by s plus 2. x2 of s divided by s plus 2. x1 of s equal to x2 of s by s plus 2. x2 of s by s plus 2. ठीक है ना? ठीक है ना? Then get the cross product and then solve it. Get the cross product and then solve it. Come on, then I can write s x1 of s plus 2x1 of s equal to x2 of s. Equal to x2 of s. Then this can be written apply inverse Laplace transform. Then I can write x1 dot. I can write x1 dot plus 2x1 equal to x2. So x1 dot equal to x2 minus 2x1. This is equation number 2. x1 dot equal to x2 minus 2x1. Similarly, second one you write cross product s x2 of s plus 2x2 of s equal to u of s. Equal to u of s. Come on, this can be written as what you can write? Apply inverse Laplace transform. Then what happened? x2 dot plus 2x2 equal to u. Then x2 dot equal to what? U minus 2x2. This is equation number 3. And next cross product it here also. x3 of s plus 3x3 of s equal to u of s. And now apply inverse Laplace transform. x3 dot plus 3x3 equal to u. So x3 dot equal to u minus 3x3. This is equation number 4. Now write the state model. Now write the state. Be remember X1, in the X1, highest number of repeated poles should be there. Next decreased by 1, next decreased by 1, like that. For example, see, first I'll write the state model here. After that, I'll explain. X1 dot, X2 dot, X3 dot is equal to X1 dot linked with X1 by X1 dot linked with X1 by -2, X2 by 1, input by X3 by 0, input by 0. X2 dot linked with X1 by 0, X2 by -2, X3 by 0, input by 1. Next X3 dot 0, 0, -3, input by 1. And Y. Y is a partial fraction coefficients. Y is a partial fraction coefficients. Partial fraction. So what are the partial fractions? Tell 1, -1, 1. Y, 1x1, -1x2, 1x3. Same thing. 1, -1, 1, -1, 1. That's all. This is the state model. Okay. Right. Break is 7:30. We'll take break at 7:30. Right. See here, listen all of you. C matrix is simply partial fractions. C is simply partial fraction coefficients. And A matrix is, listen, this repeated roots. Actually, all the poles you have to write diagonally. Yeah? All the poles write the diagonally first. So what are the poles? Tell. What are the poles? -2, -2, -3. Poles are what? -2, -2, -3 diagonally right. Whenever same number repeated, above that should be 1. Whenever same number repeated, above that should be 1. First diagonally write -2, -2, -3. Same number is there means above that 1. In case here also -2 is there, above this should be 1 here. Remain all are zeros. Remain all are 0. 0, 0, 0, 0. That's all. Like this you have to write. So, but here we are having it is not same number. Here -3. So -3 means here it will be like this. ठीक है ना? See, देखो -2, -2, -3. Same number repeated above that one. This repeated roots wherever represented, that is called Jordan block. This is called Jordan block. Repeated roots wherever represented, that is called the Jordan block. Repeated roots are represented. That region is called the Jordan block. So C is the partial fraction. So B matrix, when you come to the B matrix, 0, 0, 0, 0, here, first 0, 0, 0, end of the Jordan block should be 1. End of the Jordan block. And second block is, end of the second block is what? 2 blocks only, 2 rows only. So end of the Jordan block should be 1 in the B matrix. End of the Jordan block equivalent element in the B matrix should be 1. End of the Jordan block equivalent element in the B should be 1. Below all are ones, above all are zeros. Below all are ones only. Above all are zeros only. Below all are ones, above all are zeros. Below all are ones, above all are zeros. So like this you have to write the answer. C is the partial fractions. C is the partial fractions. Okay, na? You write one question directly, for example. You write one question directly. Come on. You write one question directly. One question directly write. Write state model. y of s by u of s equal to 1 s plus 1 1000 immaterial, because in the partial fraction that term is eliminated. So s plus 5 whole cube into s plus 10, for example. So this can be written as what? Tell y of s by u of s equal to can be written as some k1 by s plus 5 whole cube plus some k1, k2, k3 you find in your home. S plus 5 whole square plus k3 by s plus 5. K3 by s plus 5 plus k4 by s plus 10. K4 by s plus 10. Find k1, k3, k4 values by yourself. Now write the A matrix, come on. A matrix. So all the repeated roots diagonally. So minus 5, poles represent diagonally, minus 5. Then what happened? One more root is there, minus 10. So minus 10, minus 10. Same number repeated above that should be 1. Same number repeated above that should be 1. Remain all are zeros. Remain all are zeros. Come on, right? Remain all are means what? Here 0, here 0, here also 0, here also 0, here 0, here 0, here 0, 0, 0, 0. That's all. So this is called the Jordan block. This total is called JB, means Jordan block. Next B matrix you write. B matrix. End of the Jordan block should be 1. End of the Jordan block means third element. Third element should be 1. Below all are 1. Above all are zeros. That's all. Below all are 1s. Above all are zeros. C matrix partial fraction. That means K1, K2, K3, K4. Like this. C matrix is partial. So this is the what? DCF form. Okay, na? Okay, na? This is called JCF form. That is Jordan canonical form. This is Jordan canonical form. Okay, na? If answer given in CCF, you expand and then write. You should observe the options. But generally, factors given means no doubt they will give only in the either DCF or repeated roots means JCF. And factors given means they will give in DCF only. If answer not in DCF, then you write in CCF also. Expand and then you write in CCF. Nothing wrong. State model is not unique. We can write the what different ways the state model. Okay. Sorry, take the break better. Okay. One break or continue? Break na? Okay. Right, break will take. How to convert CCF means what, man? Expand it, that's all. You expand. Then write. Expand it, simply expand. Expand karo. And then write whatever the procedure I told you, write it. That's all. Okay, take the break. Right. Right. Next. End of the Jordan block should be 1. Below all are 1, above all are zeros. That's all. End of 1, 2, 3. Third element 1, 2, 3. Third element 1. Below all are 1s, above all are zeros. That's all. Next. State model to the signal flow graph. State model to the signal flow graph. Write the state model. Write the state model to the given signal flow graph. Wait. One by S. One by S. One by S. Come on, write the state model. Write the state model. Right. See here, to select the state, don't find a transfer function here. And don't write. You have to write directly. Why? Because you find transfer function, which form you will write? Controllable, observable, diagonal, that is the problem. That's why you draw directly. You write directly. First, listen. To select the state variable, so for example, here, can I select x1 means? Can I select here x1? No. To select the state variable, to select the node as a state variable, the incoming branch to that particular node should be an integrator. Anywhere node you are selecting as a state variable x or x1, the incoming branch to that particular node, especially incoming branch to that particular node, means 1 by s, incoming branch must be integrator. And before that node should be differential state variable x dot. Unless until x dot integrate, we don't get x. Unless until x dot if integrate, we don't get the x. We don't get the x. Okay, na? So x dot integration x, like this you have to. So that means here integrator is there. I can select here x1, here x1 dot. Whenever integrators are cascaded, increase the order of the differentiation, x2 dot, x3 dot. Whenever integrators are cascaded, increase the order of the differentiation. You have to increase the order of the differentiation. Okay. To select the node as a state variable, to select node as a state variable, node as a state variable, to select node as a state variable. The incoming branch must be integrator. The incoming branch must be integrator. And before that node, it should be differential state variable. Before that node, it should be differential state variable. You can be remember. Okay. And whenever integrators are cascaded, increase the order of the differentiation. Whenever integrators are cascaded, increase the order of differentiation. Whenever integrators are cascaded, increase the order of differentiation. Differentiation. That's all. X1, X1 dot, X2 dot, X3 dot, and so on. You have to write. Now write the node equation. That's all. The problem is over. Then write the node equation. The problem is over. Come on, write the node equation of X1 dot. What is X1 dot? Tell. When you are writing node equation, you have to observe only incoming branches. When you are writing node equation, you have to observe only incoming branches. We have to observe only incoming branches. So write the equation of X1 dot. X1 dot. What are the incoming branches to this node? Tell. There is only one incoming branch, that is X2 dot. X2 dot integration. This is X2 dot. Now X2 dot integrate, what I will get? X2. X2 dot integration, you will get X2. X2 dot integration, you will get X2. Next, write the equation for X2 dot. X2 dot. Come on. What are the incoming branch? There is only one incoming branch to this node. What is that? X3 dot. Only one. This is outgoing. This is outgoing. This is outgoing. Only one incoming branch only you should observe. X3 dot integration is what? X3. Next, write the equation for X3 dot. Equation for X3 dot. Come on, write it. Equation for X3 dot. X3 dot. Come on, 1 into U. Here 1 into U. Incoming branch 1 into U. Minus 3 X2 dot. This is minus 3 X2 dot. Minus 5 X1 dot. Minus 5 X1 dot. Minus 7 X1. Minus 7 X1. So this can be written as X3 dot equal to 1U minus 3 X2 dot equal to what? X3. Minus 5 X1 dot equal to what? X2. Minus 7 X1. So this is equation number 1. This is equation number 2. This is equation number 3. Next, write the output equation. Write the output equation. Come on, what is the output equation? Tell. Y equal to, come on, Y equal to incoming branches. Observe 2x1 plus 4x1 dot, 4x1 dot plus 6x2 dot plus 6x2 dot, x2 dot. That equal to Y equal to 2x1 plus 4 x1 dot. What is x1 dot? Tell. Equal to x2. So 4x2 plus 6x2 dot equal to what? X3. This is equation number 4. That's all. Put in a matrix form. Come on. You put in a matrix form. x1 dot, x2 dot, x3 dot equal to a x1 x2 x3 plus b x1 dot linked with only x2, that means 0 1 0. x2 dot linked with only x3, 0 0 1. Input by 0. x3 dot linked with x1 by -7, x2 by -5, x3 by -3, input by 1. And y linked with 2 with x1, 4 with x2, 6 with x3. Like this you have to write. Okay. Like this you have to write. Okay. Next. Next problem. Write the state model. Come on. Come on, do it. Write the state model. Here integrators are not cascaded. Here integrators are not cascaded. Write the state model. Here integrators are not cascaded. So how to do? You have to select the state and differential state variable separately. You have to select the state and differential state variable separately. For example, here x1, here x1 dot, here x2, here x2 dot, here x3, here x3 dot, like this. You have to take separately state and differential state variable x1, x1 dot, x2, x2 dot, x3, x3 dot. Like this, separately you have to take it. You have to take state and differential state variables separately. Separately you have to take it. You have to take it separately. Okay, na? So it is nothing wrong taking here x1, x1 dot, here x2, x2 dot, here x3, x3 dot. It is also correct. We can take in vice versa also, it is correct. But how to identify in the exam means The most 99% they'll mention where taken x1, x2, x3. They'll mention it. If you don't mention, you have to observe the options. Based on the options, you have to select the where x1 is there, x2 is there, x3 is there. For example, see, -4 linked with x1 or first column or last. For example, here x1, x2 dot, x3 dot is there. That -4 is there in the first column or last column, you should observe. If it is there means this -4 is there means this is x1. In case here -4 is there in all the 4 options means here you have to select x3. You have to observe the options and then you have to proceed it. But most of the time they'll mention, you don't need to worry. Now come on, write the node equations. Write the node equations. Come on. Write the node equations. Come on. So this is x1. Come on. What is x1 dot tell? What is the equation for x1 dot? So 3x2, 3x2. This is 3x2 minus 4x1. Minus 4x1. Next, x2 dot. Write the equation for x2 dot. Come on, what is x2 dot? 1 into u minus 5x2. Next, again similarly write x3 dot. Come on, 2 into u minus 6x3. 6x3. Next, y. Y equal to what? 7x1 plus 8x2 plus 9x3. 9. Come on, get the answer. Get the answer. x1 dot, x2 dot, x3 dot. That equal to here a x1, x2, x3 plus b into u. Now x1 dot linked with x1 by x1 dot linked with x1 by -4, x2 by 3, x3 by 0, input by 0, x2 dot linked with x1 by 0, x2 by -5, x3 by 0, input by 1, x3 dot 0, 0, -6, 2. Similarly, y linked with 7, 8, 9. Like this. Okay. Next problem. Write the state model. This is also important. They are giving signal flow graphs. They are asking the state models. Most of the time transfer function they are giving, they are asking state model. Second is signal flow graph and state model. These two only important. Differential equations very rare. Last 30-40 years questions you observe, you may find 1 or 2. That's all, not more than that. These two only important. Come on, do it. Come on, do it. Come on. Write the state model. Come on, do it. Select the state variables. Select the state variables. Listen. Can I select here state variable? No, because there is no integrator. I can select here state variable as x1. Integrator, that means x1 dot. Cascaded, that means x2 dot. x2 dot. Now write the node equation. That's all. Automatically you'll get the answer. What is x1 dot tell? x1 dot equal to what? Oh, one incoming branch is what? x2 dot integration. x2 dot integration is x2. Again minus 1. Minus 1 into x1. This is equation number 1. Next x2 dot. Below what is x2 dot tell? 2u minus x1. 2u minus x1. This is x2 dot. 2u minus x1. This is equation number 2. Now we have to write equation y. When you want to write equation y, here you have to get the equation. What is equation here tell? x1. This is x1 plus x1 dot. x1 plus x1 dot. So x1 plus what is x1 dot tell? x2 minus x1 dot equal to what? x2 minus x1. x2 minus x1 minus x1 cancel. That means this is x2. That means y equal to what? 0.5 times of x2. Y equal to 0.5 times of x2. Now come on, write the state model. x1 dot. x2 dot. That equal to x1 dot linked with x1 by minus 1, x2 by 1, input by 0, x2 dot linked with x1 by minus 1, x2 0, input by 2, and y is linked with x1 by 0, x2 by 0.5. So like this you have to write the state model. Okay. Correct. Number of integrators. Same. That is order only, na? Second order 1 by s square. Second order 2 state variable. That's all. Next. Write the state model. Here integrators are given in the feedback path. Come on, do it. Here integrators are given in the feedback path. Come on, do it. Come on. So what happened here? Integrators are given in the feedback path. Come on. So whenever integrators are given in the feedback path, select the state variable from input to output. Select the state variable from input to output. Integrators are given in the feedback path means select the state variable from input to output. Okay. Integrators given in the feedback path. feedback path. Select the state and select the state variable. Stream is state variable. Select the state variable from input to output. Command select the state variable. So here, what I should select here, tell x1 dot, yes or no? Here x1 dot I should select. X1 dot I should select. X1 dot. I should not select here x2 dot. Because if x2 dot, if you select here x1, you will get x2 dot never becomes equal to x1. Na? X2 dot may becomes the what? X3. X2 dot may become the X3, but not equal to what? X1. That's why don't select here X2 dot. And here X2 dot to here X1 dot to here X1 means it is wrong. So always select from input to output. Input to output. If you select here X2 dot, here in case X1, for example, here X2 dot is selected. Here selected X1 dot. Here in case X1. What is X1? It will become X2 dot. 1 into x2 dot. And what happened? X2 dot again this one plus x1. So that means what happened? The equation is going to be wrong. That's why always select the state variables from input to output, generally when integrators are given in the feedback path. Okay. Right. Now command select it. Here what happened? X1 dot. X1 dot. Now integrator means here what happened? X1. Don't select here X1. Don't select the state variables here. Don't select the state variable. Why? Because why you should not select means listen. For example, here X1 you written. X1 equal to what? Equation you write 1 into U, 1 into U. Then X1 dot integration. X1 dot integration is what? Plus X1. Don't write like, don't come like this. Minus X1, don't write. The direction you observe. The direction you observe. So X1 dot integration means X1. X1 cancel. You don't get equation at all. So that's why you should not select the state variable. Be remember, don't select state variable when integrators are given in the feedback path. Simply select some other, so like A. You select A. Write the equation for A. What is A? Tell 1U plus X1. X1 dot integration is what? X1. But what is it? What we want? We want X1 dot. We don't want A. So X1 dot I want. What is X1 dot? Tell X1 dot equal to minus 1 into A. That means minus of what is A substitute? What is A is substitute? Minus 1 into U. A is called 1U plus X1. So that means what is X1 dot? X1 dot equal to minus 1U minus X1. That's all. Like this you have to solve. This is equation number 1. Similarly, here X2 dot. So here X2 dot, here select the B. Now write the equation B. What is B? Tell 1 X1 dot, 1 X1 dot plus X2. Plus X2. Then B equal to what? What is X1 dot? Tell. What is X1 dot? Here itself is their substitute. X1 dot equal to what? Minus U minus X1 plus X2. Now I don't want B. What I want? X2 dot. X2 dot equal to what? Minus 1 into B. Then what is X2 dot? Tell. X2 dot equal to minus 1 product to this. Then 1U plus X1 minus X2. This is equation 2. Next, Y. Y equal to what? Tell. X2 dot. Y equal to X2 dot. What is X2 dot? Tell. 1U plus X1 minus X2. This is equation number 3. Then put in a matrix form. X1 dot. x1 dot linked with x1 by -1, x2 by 0, input by -1, x2 dot linked with x1 by 1, x2 by -1, input by 1. Next, y. Here y matrix linked with D also. Y is linked with U also here. So y is x1 by 1, x2 by -1, and input by 1. So like this, you have to write the state model to the what? Like this, you have to write the state model to the signal flow graphs. Next one. State model to electrical network. Actually, it is not required. They are not asking anything, but you should have idea. So we'll solve that also. State model to electrical network. State model to electrical network. ठीक है ना? Right. Write the state model to the given electrical network. Write the state model to the given electrical network. Come on, write the state model. Write the state model to the given electrical network. You write the procedure first. Select the state variable. Select the state variable as voltage across capacitor and current through inductor. Select the state variable as voltage across capacitor and current through inductor. So next, second step. Number of state variables equal to sum of inductors and capacitors. Number of state variables equal to sum of inductors and capacitors. Inductors and capacitors. Step 3. Write independent KCL and KVL equation. Write independent KCL and KVL equations. At capacitor junction, apply KCL. At capacitor junction, apply KCL and KVL through inductor. and apply KVL through inductor. Resultant equation consists only state, differential state, and differential state, input and output variables. Come on, do it now. Select the state variables. Voltage across capacitor means VC. Current through inductor means IL1. Current through another inductor means IL2. That means what is the state vector? VC, IL1, IL2 is the state vector. Next, KCL at capacitor junction. Here KCL you have to apply. KCL at capacitor junction. Here consider current IC. Now tell IC equal to what? IC, living current equal to entering and living current. Now that means IL1 minus IL2. IC equal to IL1 minus IL2. Yes or no? IC equal to IL1 minus I2. But IL1, IL2 state variables. IC is not state variable. Convert IC into state variable. That means what I should write? C dVc by dt. IC is called C dVc by dt. That equal to what? IL1 minus IL2. This can be written as Vc dash. Vc dash equal to what? IL1 by C minus IL2 by C. This is equation number 1. Next, KVL through inductor 1. Like this you apply KVL. Here apply KVL through inductor 2. Both the equations you will write. Now write KVL 1. KVL 1. KVL through inductor 1. Come on, VI equal to IL1 into R1. Check it. IL1. Here same current na, IL1 into R1 plus IL1. Bolo. Next, what is the equation you will get? L1 d IL1 by dt. Yes or no? L1 d IL1 by dt. So L1 plus L1 d IL1 by dt plus VC, voltage across capacitor, plus VC. Now this can be written as differential state variable left hand side. IL1 dash is left. So IL1 dash equal to VI by L1. VI by L1 minus R1 by L1 into IL1 minus VC by L1. This is equation number 2. Next, KVL through inductor 2. KVL through inductor 2. Now write VC equal to L2 dIL2 by dt plus plus IL2 into R2. This current IL2 into R2. Differential state variable left side. IL2 dash equal to VC by L2 minus R2 by L2 into L2. Generally, they don't ask this much big. Simply state vector is how many state variable, like that they may ask. Yes. Next, what is the output? Tell V not equal to what? IL2 na into R2. V not equal to IL2 into R2. Now put in a matrix. VC dash, IL1 dash, IL2 dash. VC, IL1. Here VC dash linked with what? Come on. VC dash linked with IL1, IL2 with 1 by C. VC dash with VC0, IL1 by 1 by C, IL2 by minus 1 by C. Next, IL1 dash. IL1 dash linked with VC by minus 1 by L1. Next, IL1 by minus R1 by L1. Next, IL2 by 0, input by 1 by L1. Next, IL2 dash with VC by 1 by L2, 0, minus R2 by L2, 0. Then V naught, bolo, 0, 0, R2. Because R2 linked with only IL2. That's all. That's all. OCF not required. OCF means just convert, transpose it. Remember, that's all. OCF model means first CCF you write and then take the transposes. Not required more than that. Right, next. Transfer function from state model. Default, if they don't mention, you write only CCF. Nothing mentioned, just write state model, write in CCF. Factors form in DCF. Don't write in OCF. There is no single question in OCF. They don't ask. Even if you ask, write CCF, then take the transpose. That's all. Transfer function from state model. This is very important. This is very important. Transfer function from state model. Write the transfer function from state model. What is the formula for transfer function? Anybody? Transfer function equal to C into SI minus A inverse B plus D. So this can be written as C into SI minus A inverse means what? Adjoint of SI minus A by det of SI minus A B plus D. Remember these formulas. You remember this, ठीक है ना? ठीक है? Right. Det of Si minus A equal to 0 gives the characteristic equation. Det of Si minus A equal to 0 gives the characteristic equation. Characteristic equation is det of Si minus A equal to 0. Roots of characteristic equations are poles. Roots of characteristic equation are poles, which are called eigenvalues. That's all. Note down one problem. Note down one problem. Find the transfer function to the given state model. Find the transfer function to the given state model. Find the transfer function to the given state model. X dot equal to -1, 0, 1, -1, x plus -1, 1u, y equal to 1, -1. Come on, do it. First write Si minus A. I'll take this problem in the next page. Write right. Wrong. 1 minute. One minute. Right. Come on, write the state model. Write the transfer function. So I'll write one more time here the state model. X1 dot equal to -1, 0, 1, -1, x. Plus, come on, Si minus A, you write. Come on, get the answer. Right. So first Si minus A. Si minus A. Outright Si minus A means just add S diagonally. You add S diagonally. For example, here S. Here also S. Right? Add S diagonally. Just add S diagonally and change the sign of all the coefficients. Change the sign. Plus, plus, minus. Here is also minus, but 0 is there. No need to put minus. Then it is called Si minus A. Add S diagonally. Add S diagonally and change the sign of all the coefficients. So to get Si minus A, to get Si minus A, add S diagonally. Add S diagonally. add S diagonally and change the sign of all the coefficients. And change the sign of all the coefficients. All the coefficients. That's all. So now we got Si minus A. Now write the transfer function. So transfer function equal to, what is the adjoint of ABCD? Adjoint of ABCD equal to what? Come on here, D. This two diagonally shifted, this to opposite side. That means DA minus B minus C. It is called adjoint. Now come on, write transfer function. First C. What is C? 1 minus 1. 1 minus 1 C. Next, adjoint of Si minus A. Adjoint. Diagonally change. S plus 1, S plus 1. Take opposite sign. Here plus 1. Here 0. Adjoint. C. Adjoint of Si minus A. Dekho formula. C. Adjoint of Si into B. Into B. What is B? Tell. Minus 1. 1. And plus D. What is D? 1. Divided by det of the matrix. What is the det of the matrix? Det of S plus 1, 0, minus 1, S plus 1, det. Now tell the answer command. Transfer function equal to 1 minus 1. Command product it. Product, this two product, minus S, minus 1, 0. Next, minus 1. Plus S plus 1. S plus 1 divided by what is the denominator? S plus 1 whole square. So plus 1. That equal to plus 1 na? D matrix. Plus 1. That equal to, come on, 1 1 cancelled. Plus 1 minus 1 cancelled. Now again do it. Product these two. What I will get? Minus S minus 1 minus S divided by S square plus 2S plus 1 plus again D matrix 1. And now simplify. Get the answer. LCM you take. Minus 2S minus 1. LCM if you take denominator S square 2S plus 1. And here what I will get? Plus S square plus 2S plus 1. These two cancel. Then transfer function is what? S square by S square plus 2S plus 1. That's all. Or we can write S square by S plus 1 whole square. That means what is the characteristic equation? Tell. Characteristic equation is what? S plus 1 whole square equal to 0. So poles locations are what? What are the poles? Tell. S equal to minus 1, minus 1. Minus 1 comma minus 1. That means what? Two poles are repeated at minus 1. Two poles are repeated at minus 1. Two poles are, and it's just like critical damped system. Just like critical damped system. Critical damped system. That's all. Okay, na? Si minus A. Correct only, na? What is Si minus A? Take, add S diagonally, change the sign of all the coefficients. Correct only. Sign of all the coefficients means it will become plus, plus, here minus. Correct only. What is the matrix I given? Here opposite sign, S plus 1, S plus 1, minus 1. Correct. There is no mistake. Okay. Right. Next one. Si minus A means Si minus A. S into identity matrix minus A. Opposite signs you have to take for A. Correct only. Right, next one. In adjoint, where is mistake? Adjoint to this you have to apply. Diagonally change. And opposite sign, this is opposite sign means +1 only. Where is the mistake? Adjoint, this to diagonally change, -b minus c. So there, this will be +1, correct only. Right, next. Do first perfectly, okay? Write it. Next question, one more question. Come on, solve it all of you. Find the transfer function. Next question. Find the transfer function to the given state model. Find transfer function to the given state model. Come on, Guruji. X1 dot. Yeah, simply X dot you write. Why X1 dot? Wasting the time. -2, -3, 4, 2. X plus 3, 5. Come on, U. Y equal to Y, 1, 1. Come on, Guruji. Find the transfer function. Come on, Sisha. Come on, jaldi, jaldi. Come on, solution. First, Si minus A. Add S diagonally. Change the sign. Means plus, plus, minus, minus. So, add S diagonally. Change the sign of all the coefficients. This is called Si minus A. S added, minus become plus, 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 minus, minus. Correct. Now, write transfer function. C means 1, 1. Now adjoint to apply. So S minus 2, S plus 2. This will become -3. This will become +4. Into B, 3, 5. Divided by det. What is det? Det of S minus 2, -4, 3, S plus 2, no? S plus 2, 3, -4, S minus 2. Det of Si minus A. Now get the answer. 1, 1. Now product it. Come on, 3S minus 6 minus 15. Next 12 plus 5S plus 10 divided by S plus 20 S minus 2. S square minus 4 plus 12. Then solve this transfer function. 1, 1, 3S minus 21, 5S plus 22 divided by S square plus 8. Now 1, 1 you product. 3S minus 21 plus 5S plus 22 divided by S square plus 8. So 8S plus 1 by S square plus 8. Then characteristic equation is S square plus 8 equal to 0. S equal to what? Plus or minus j root 8. So that means two poles lies on imaginary, plus j root 8 minus j root 8. System is what? Marginal stable. Marginal stable, just like undamped system. Just remember the formula and substitute ABC matrix and SI minus A, then automatically you will get the answer. Okay, na? Automatically you will get the answer. Very good. Right. Next, we'll go for solution to the state equation. This is also very important. Solution to the state equation. Solution to the state equation. What is the state equation? Tell. X dot equal to AX plus BU. It is called non-homogeneous state equation. Non-homogeneous state equation. U of S is 0, then it is called homogeneous, otherwise non-homogeneous. I don't do the derivation here. I'll write the directly answer. Method 1, Laplace transform. We don't require derivation. Laplace transform method. Laplace transform method. Then just you have to apply Laplace transform and then you have to find it. Okay. Simple as, for example, Laplace transform apply, what I will get? X of S minus X naught. You have to consider initial conditions. A X of S plus B U of S. That's all. Simplify this. X of S terms, take it common. So that means A X of S minus A X of S equal to X naught plus B into U of S. X of S, take it common. What you are getting? Si minus A equal to X naught plus B U of S. We don't require the derivations all. X of S can be written as Si minus A inverse into X naught plus Si minus A inverse B into U of S. Then apply inverse Laplace transform. This is the equation you have to remember. X of t equal to L inverse of Si minus A. Si minus A inverse into X naught plus L inverse of Si minus A inverse B into U of S. This you have to remember. This is a solution to the state equation. This is equation 1 you consider. This is a solution to the state equation in the Laplace transform method. We don't require derivation. Finally, you have to remember this. And here the first term is called, ZIR, zero input response. Second term is called ZSR, zero state response. ZIR means zero input response. Zero input response. The zero input response generally will get because of initial conditions. X naught means initial condition. Zero input response, ZIR, is due to initial conditions. due to initial conditions. Due to initial conditions. Next, zero state response. Zero state response. Zero state response. ZSR is zero state means initial states are zero. Zero input means no input. Zero input means no input. That means you will get because of initial condition. Zero state means no initial states. Initial states are zero. That response you will get because of input U of S. Zero state response is due to input. Zero state response is due to input. Okay, na? Next method 2. This is method 1. Next method 2. Method 2. Classical method. We don't require. I'll write answer directly. Classical method. X of t equal to solution. I'll write e power at into x naught. E power at into x naught plus integration of minus infinity to t e power a t minus tau e power a t minus tau b u of tau d tau. This is second equation. Here also first term is ZIR, second term is ZSR. So compare ZIR terms in both. Compare ZIR terms. First we'll compare. Okay, compare ZIR terms. Come on, you compare. E power at x naught equal to what? Laplace inverse of this. X naught cancel. That means what I can write? Tell e power at is nothing but what I can write? Laplace inverse of x naught cancel. X naught is a constant. We can take it common. We can get it cancel. Laplace inverse of Si minus A inverse. So e power at equal to Laplace inverse of Si minus A inverse. This is called actually pi of t. This is called state transition matrix. It is called state transition matrix. It is called state transition matrix. Okay, STM. Simply it is called STM. Most of the time they are asking this only. Find STM, find STM. Okay. State transition matrix. Find STM. Next. See e power at equal to pi of t. E power a t minus tau equal to what? Pi of t minus tau. E power a t minus tau equal to pi of t minus tau. And Laplace inverse of Si minus A inverse equal to pi of t. That means what is Si minus A inverse? Laplace of pi of t. That equal to pi of S. So Si minus A inverse equal to pi of S. If anywhere written pi of S means given Si minus A inverse. Now see here. This I can write it as what? Pi of t minus tau I can write. And here Si minus A inverse I can write it as what? Pi of S I can write. Now compare ZSR terms. Compare ZSR terms. Compare. Final equation, remember enough. We don't require all these things. What you have to remember, I'll tell. You remember first pi of t. STM you remember. Mainly STM remember. Next last equation you remember. Compare ZSR. So if you compare ZSR, integration of minus infinity to t, phi of t minus tau, b u of tau d tau must be equal to Laplace inverse of phi of s, b u of s. That's all. That means in this equation we can replace by Laplace. Finally, what I can write S of t is the solution to the static equation. All these three you have to remember actually for 1 mark bit. Sometimes they will ask the solution to the static equation. They'll give this, and they'll give the third one also. So that's why all the above option may be there, or multiple select answers. All the three may be there. So you should remember. So third one is e power at in STM. This is called in STM. X naught plus Laplace inverse of phi of s, b u of s. Finally, remember this enough. So phi of t, x of t. This is equation 3. You remember this. So e power at. But what is e power at? Laplace inverse of si minus a inverse. What is phi of s? Si minus a inverse. Be remember that. Okay, na? Phi of s is what? Si minus a inverse. E power at is Laplace inverse of si minus a inverse. Be remember that. So this is the what? Solution to the state equation. Next. It is a solution to the state equation. Okay. Yes, ZIR is natural response, ZSR is forced response. Correct. Correct only. Right. Next. Next one is, listen. Solution to the homogeneous state equation. Solution to the homogeneous state equation. Another 2-3 minutes. Homogeneous state equation. That is x dot equal to ax. So this is called homogeneous state equation. U should be 0. U of s, U should be 0. Then what is the solution? U0 means this simply, U0 means solution is nothing but ZIR, 0 input response. X of t is nothing but ZIR, 0 input. Input 0 na, 0 input response. What is 0 input response? E power at, this is ZIR only na. This is ZIR, this is ZSR. So that means e power at into x naught. That is nothing but Laplace inverse of si minus a inverse si minus a inverse into x naught. Into x naught. That's all. This is the solution to the homogeneous state equation. Next, properties of STM. After properties, we'll close. Properties of STM, state transition matrix. All of you write STM matrix, phi of t equal to e power at, phi of t equal to, write STM matrix, all of you. E power at, that equal to Laplace inverse of si minus a inverse. First property, phi of 0 equal to how much? I, identity matrix. Don't write 1. E power 0, 1 means don't write 1. Identity matrix. Identity matrix. Second, pi power of k of t equal to e power at whole power k. That means what I can write? E power a kt. So that equal to what I can write? Pi of kt. That means indirectly pi inverse of t equal to pi of minus t. Third one. Pi of t1 plus t2 equal to, simply exponential term is substitute, you will get pi of t1 plus pi of t1 into pi of t2. Pi of t1 plus t2 equal to pi of t1 into pi of t2. Fourth one, pi of t2 minus t1 into pi of t1 minus t0 equal to pi of t2 minus t0. Next one, last one, fifth one, d pi by dt at t equal to 0 is nothing but a. You want to differentiate a e power 80, t0 means you will get a. Okay. These are the properties of STM. For tomorrow we'll solve the problem. We'll solve the problems tomorrow. For that, remember this as well as remember this one, pi of t, remember, and remember even this also. You remember this so that you can solve the problems. Okay. So if you have any doubt, you can ask. You can ask the doubts. Tomorrow, same 5 o'clock, I'll start. Okay. Right. We'll solve the problems tomorrow. If you have any doubt, you can ask. Sri Charan.
Sir, in page number 25, sir.
Page number
25.
Right.
Sir, here in x1 of s, we can directly expand that s plus 2 whole square. That another answer will come, sir.
X1 of s, tell loudly.
X1 of s, if s plus 2 whole square is expanded, another answer will come now, sir.
Why you will expand? Then expand which form you will write?
X1 double x1 2 dots of s, x1 2 dots.
Then what you will do after that?
Okay.
Canonical means standard. You should not change. Canonical means standard. You should follow that steps. That's all.
Okay.
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 That is a standard representation. We should not change it.
Okay, sir.
If you expand, then fine. First itself we can expand. We can write in controllable form. It is not required to write in this diagonalization form.
Yes, sir.
You should not expand.
Okay, sir.
Next, Abdul.
Sir.
Tell.
ఇది మనము ఇంటిగ్రేటర్ అంటే ఒకసారి డయాగ్రామ్
Tell loudly.
సార్ ప్రాబ్లం బ్యాక్ 24. 24 పేజ్ నెంబర్.
Page number 24. Tell.
ఇప్పుడు మన సిగ్నల్ ఫ్లో గ్రాఫ్ ఉంది కదా సార్, సిగ్నల్ ఫ్లో గ్రాఫ్ ప్రాబ్లమ్.
పేజ్ నెంబర్ అయ్యా
22 అనుకుంటా సార్. 22.
Signal flow graph problems after this. Tell now. This problem.
సార్ ఇది ఈ ప్రాబ్లం సార్. సార్ మనం ఇక్కడ ఇంటిగ్రేటర్ అంటే ఇది ఇంటిగ్రేషన్ x1 వాల్యూ ఎలా తీసుకున్నా నాకు అర్థం కాలేదు.
I told na. What you study this statement? You read this statement. Wherever 1 by s is there, you have to select the state variables. That's all.
Okay, sir. State variables x1 x and integration of
1 by s is there. After that, state variable. Before that, differential state variable you have to take. If 1 by s is not there, you should not select.
Okay.
That's all.
Ingot last, sir. State last 37.
37.
30 last 37.
Tell.
సార్ ఇది ఇప్పుడు మనం కంపేర్ జీరో ఇన్పుట్ రెస్పాన్స్ అంటే ట్రాన్సియంట్ స్టడీ స్టేట్ అలాంటిదేనా రెస్పాన్స్? అదేనా?
ఓకే,
అదే కదా సార్.
అంతే. ఫస్ట్ ది ట్రాన్సియంట్, నెక్స్ట్ ది స్టడీ స్టేట్. ZIR is transient, ZSR like steady state. Input is there means steady state only. No input means transient.
ఇప్పుడు ఏది తీసుకుంటాం సార్? ZSR అంటేనే
ట్రాన్సియంట్ అయ్యా. దిస్ ఇస్ స్టడీ స్టేట్.
ఓకే సార్. ఓకే సార్. ఓకే సార్, థ్యాంక్ యూ.
Chandrababu.
Sir, 30F, sir.
Tell.
30F. Sir, here you taken as A na, instead of X1. I did not got it, sir. A, B.
If I select X1, it is getting cancelled, na? If here I select here X1, what is the equation? Tell. X1 equal to, come on, tell. 1 into U, na?
1 into U. Yes, sir.
X1 dot integration what? X1. X1 cancel. Are you getting any equation?
No, sir, nothing.
That's why you should not select the state variables when the integrators are given in the feedback path.
Okay.
ठीक है ना?
ठीक है, sir. Got it.
Okay. Next, Akans.
Hello.
Tell.
The 22F.
20?
23.
Tell.
So here we are getting C value matrix above method 1.
C matrix is?
So means for A and B, you said now that we can write poles and we can write partial fraction terms. And
Yes.
For C, there will always be 1, 1, 1.
C is always partial fraction. You are writing B means C is always 1, 1. In case B you are writing 1, 1 means C is partial fractions.
Okay, this is in case of DCF.
Only in DCF. Remaining
Okay.
things it is not valid.
So means only 3 forms will be asked and we will learn these 3 forms, then it will be
OCF they don't. OCF you have to write from only CCF.
Okay.
I told
Sir,
na
Yes, I understood that.
that formulas you remember.
Okay, sir. So, and this DCF form in options, if it will not be in this form, then we have to calculate by other CCF form, or there is something to convert.
Roots are given mean DCF form only, that's all.
Okay, sir.
Compulsory roots are given, factors are given mean they will give answer in DCF only.
Okay, sir.
Okay.
Yes, thank you.